My name is Professor Victor Chang. I'm very honored to give a talk. The title of the talk is called Development of a Diabetes Diagnosis System Using Machine Learning Algorithms. And we have published this paper on a journal called IGDSD, IGI Global. And we are going to put the information at the end of this talk. Then we are going to talk about a research objective as follows, because you may have noticed that we have given two other similar talks on diabetes. But however, in this world, even you're doing the same research, but every time the challenges are different, data set can be different, and the focus can be different. Especially you may have to try different factors and different emphasis and see what the results are. So first of all, during 2020 and 2021, during the COVID time, we have a web application that allow users to evaluate or not whether a patient has diabetes. And the project was finished. But however, we felt that it's very important to disseminate the lessons learned. And then we use the machine learning algorithms such as the SVM, decision trees, and random forest to perform high-level analysis. And we critically visualize the data set and find the correlation between several features and data set, and to demonstrate the meaningful insights and to report to the research community. And finally, we develop a general flow to evaluate the outcomes of the M products critically, so we have at least understand what are the issues, and also go in further when we realize there are some very interesting observation. We are going to tell all of you. Then first of all, literature review is the one that we go for. But please, if you have time, read our paper, because it will explain to you. At the beginning, we talk about data mining. It's a technique to extract the data and to then have the insights, and then understand what we have done. And then further on that, we can then make predictions based on our past experience and our current performance. Therefore, data mining application can be used in many areas, such as the market analysis, healthcare, fraud detection, CRM, manufacturing, engineering, education, financial banking, lie detection, and so on. But not only on data mining, but nowadays we have moved forward into higher level domains, such as data science in general, and combining with the AI. And then diabetes prediction and AI techniques. There are a lot of different methods. One of them is called support vector machine, SVM, that has been very effectively used and analyzed. However, sometimes when we run the SVM, it may take a much longer time due to the way this is designed and implemented. And then we use also a lot of neural networks, because neural networks can then perform a lot of analysis and also have a very high level of reliability. Then we also use decision tree to help us to have a better analysis. And then if we want to make it further, we can then even perform gradient boosting in decision tree, because it will allow us to optimize our results. And then naive Bayes is also another technique. And if you have any queries, please also read our paper. Then the methodology, of course, as I've said earlier, we have done similar work, and there are also two papers published. But every time research focus can be different. That's the reason we want to show that if we are having a different focus, and then what the results are. But every subject is always having a very different objective, and also a different emphasis. And what we're going to talk about the algorithm in pseudocode first, and then followed by the workflow, because they are all in the same objective, but then presented in different ways. So it's very important for us to know what we're going to do. But then this is just one example. First of all, we train the data set. Then we have the value to predict variable in testing data set, so that we put them in this query. And then you can also imagine this list of arrays from F1 all the way to Fn. So the output will then focus on the class of the testing data set. So what are the steps involved? First of all, we read the training data set. and then we then have a very good performance to read the data set. Then we calculate the mean and standard deviation of the predicted variables in an individual class, because now every data means every patient, and each person can be very different from one another. Therefore, we then can, first of all, get all of the class, but also we then calculate the mean and standard deviation to have a better understanding about an individual. And then we repeat this process. We calculate the probability Fi, which means that from the predicted value of the testing data set, or using the Gauss density equation, because Gauss density equation will help us to obtain a more reliable and also more accurate results. And also we then perform this until the probability of all the predicted variables has been calculated. Then we get all the calculations, then we calculate the likelihood of each class, because when we understand the data as the individual and also as the group, then we can understand how the whole group then can perform. And then as a result, then we may be able to have a better understanding. So prediction need to be built on top of a full understanding about what you have done and what this group has performed as a whole. And then based on the previous result and the observation of the current circumstances, then we may make some meaningful prediction. Then get the greatest likelihood. The greatest likelihood means that we can also even perform that several times. Then the results that shows are more frequently, and it will be the one we go for. So just to explain to you how it works. So we start from here. We start, for instance, every data set, every patient, you have a attribute A. So attribute may mean, for instance, BMI, or for instance, glucose level in the diabetes patient, or it may mean even pregnancy. I'm going to explain that a bit later. Then we then transverse attribute list for A in examine node. So we examine that. Then after that, we then find the probability using the value of A in the class. Because if we have a higher probability, it means that there must be something very important to this data set or this patient. Then we update the class of the A, because if let's say we can perform a few things. First of all, we can rank in the sequence of importance. We can also rank this in accordance to the likelihood for the attribute that we're looking for. Though maybe a particular attribute or variable we're looking for. Then all the values, of course, we need to understand all the values. And then if we are in doubt, we then do this again until we are sure, until we are certain. Then we can then proceed. And is there any other attribute we need to also understand? Do we miss anything? Or is there anything we need to go back? And if so, oh yeah, we then start again. And if no, then we come to end. So at least we don't miss anything. The crucial part is that we don't miss anything, and we do things correctly and also step by step, so that the accuracy is also very importantly built on a very strong foundation, and that will help us to achieve our goal. Then the process of machine learning, for instance, a data set that comes with a training and testing, and then we then can perform the building predictor models. Then again, when it's successful, we can perform assessing and selecting the model, because we need to ensure that before we perform using the algorithm to run, and everything is all in the right track. And then, of course, we have to have a certain meaningful prediction and have a very high levels of certainty before we then perform the analysis. Then, of course, then we then can select the most suitable models for our analysis. So I'm going to explain the steps involved. This may be easy for some people, but please do not miss anything. If we miss any step, you are not going to get a result. So we also ensure whatever we do, we follow the process. We follow the golden rules. That the golden rules is a result of our experience and our analysis throughout years of hard work and also our own training. So data collection, of course, is important. that depends on which institution or which project or which supervisor you work for. But of course, we can collect ourselves, or we can then obtain permission to work from the community, or perhaps some kind researcher may even pull up the data set for us to analyze if you look up the Kaggle. So the data can come in different databases in different forms. Of course, data set in different form, but most people will have to analyze them in CSV file. So usually, if you work with machine learning, then CSV file will be probably much more suitable for that purpose. Then results can be analyzed and stored efficiently, making it competitive for any research project to resolve possible problems by AI and machine learning. So after collecting the data, next step is data preparation. That is in the process used to prepare the data. The process involves cleaning the data to remove unwanted information along with those redundant values. We then can perform a series of data cleaning process. And of course, sometimes there can be some missing data. We can also use other ways to make a better understanding. And also we then can ensure that before we analyze the data, we don't miss anything, or at least that the data is in a good shape. It also requires data wrangling. So there is a process that to make the data in different formats, such as merging, grouping, and concatenating, and many more. So we perform a series of data operations to ensure that it works. Data exploration. So when everything all looks fine now, the first thing is to understand the data. At least that we have some basic level of understanding about what the data is telling us. Because before we dig in further, we need to explore all the possibilities. So when the data is ready, the data exploration has been represented using various data visualization techniques that discover unseen trends from the data. The exploring data set and developing a deep understanding of the data is a critical step needed to complete every project regardless of the domain. So it gives a sense of what additional work will be performed to quantify as well as extract insight from our data. So we then can understand what needs to be done, what should be focused on. And then we will be able to follow that up. So we can perform the training of the data. The training and set is used to train a machine learning model to predict the outcome of a design. Test set is used to measure the performance, such as accuracy. Independent variables are represented as the input for process that is being analyzed. They are the cause. The dependent variables are represented as the output of the process. The dependent variable is the effect. Its value depends on changes in the independent variable. So we then perform the data. We then can use other machine learning algorithm to train the data. At least the machine will be able to get familiar with data and then understand what are the insights and then present the result to us. Then the machine learning algorithm used in this study, for instance, the first one is called decision tree. Decision trees classify data by recursively dividing the data set into mutually exclusive subsets to explain better the variation in the dependent variable under observation. In order to classify instances data points, the decision trees arrange along the tree from the root node to leaf node and to the end of the branches, as you can see like this. You then have the different nodes. They split it up. So then you split that up, and then it gives the probability for each split. So then we then can calculate that. We can also do this at the branch subtree level. A leaf node is responsible for categorizing the instance. So this is a leaf node. Then the decision and trees, branches depict several situations for making decisions, as well as the result of those scenarios. So SVM, that stands for support vector machine, it uses a concept of hyperplane to maximize the distance between the classes. A hyperplane is formed and oriented in such a way as to keep it at the maximum margin of distance from the closest data point. So as you can see this, it then calculate that. So the margins is there, and then the hyperplane is in the place. So then it finds the closest data point. In this case, is here. Then the upper bound of the generalization error is then minimized, which is also the key aspect of SVM. Therefore, SVM provides a generalized power from smaller parameter, and its performance heavily rely on the selected kernel. So the selected kernel will then perform this, and it will search to the one that is nearer, and then group them together. But also, we also try to work with MapReduce algorithm. So MapReduce can then returns output in key value form. However, it can be highlighted that different output keys have similar output keys. Then, and in MapReduce, number of the reduced tasks are fixed, as well as each reduced task is to handle all the data related to one key. That means the map outputs like 110, 115, 120. So it will then give us the value, and then we then can process that further. Of course, machine learning, you have other ways to make it better in your own definition. So there is no any answer to tell you must do A, must do B. It gives you certain freedom to do so. So random forest, the data set then divides them into subset. The random forest has the ability to consider a very large number of predictors while still maintaining efficiency. Then it follows the creation of huge number of trees. Voting process of each tree happens to find the most popular class. So when it has the most popular class, then it wins. So as I just summed that up, it goes for the majority in each set, and then becomes one unified decision. So if in case at the beginning you are not supposed to know. So in case if the yellow wins, and even there is also one defects, then the whole thing becomes yellow. And then similarly, if this becomes blue, and then the blue wins. It's like the US presidential election is very based on that. Each state then choose the candidate they vote for, and then the winners takes all. So random forest is also not just an algorithm, but also happen in real life situations, and results and discussion of findings. So first of all, this is the finding, and then we focus on a few patients, and as you can see, pregnancies is usually a very complicated area. In our last two paper and last two projects, we didn't touch that. But then because in research, you cannot say, oh, it's a difficult subject, and you try to avoid or to even not do it. That's not the right way of doing research. So in this case, that sometimes it's hard to understand, like number of pregnancy. But then for scientists, our concern is to analyze data. We should not know what happened. But then this gives you the idea. The glucose level, the higher, the worse, which means that you are more likely to get into diabetes, because this is usually measured at a particular period of time and a few times a day. And your glucose level is supposed to keep low in order not to be very inclined to diabetes. But then again, it's also not necessarily the case, because when blood pressure, it comes to the fact that for some people, under normal circumstances, they would consider high or low. But then some people may have been undernourished, or maybe some other reasons, maybe diabetic reason, or maybe health reasons, but also skin thickness. Why? Because skin thickness is the one when you inject insulin. If the thicker the skin has, then you may have certain preventive steps, which means that your injection of the insulin may not be coming to your body very quickly. And insulin level, of course, the people with insulin usually with type 1 diabetes, but then for some people, they also have a high level of insulin. But BMI is also important, because BMI is just a very general index measuring your body mass. Yeah, so body and mass. So it means that usually in the form of your weight versus your height, and then we have some simple calculation. Diabetes, pedigree function. So pedigree function means that it's a kind of the measurement to determine how likely you're going to get to diabetes, of course, age and outcome. The outcome of your analysis that will whether to determine whether you got diabetes or not, or maybe sometimes we even get from the record that the patient already got the diabetes condition. So 1 means yes, 0 means no. So this gives us the general sense about the patient, but of course there are also other patients involved. And then in this case, we use the ratio between 70 to 30. Why? Because sometimes when you are not very certain of certain things, especially when you have the pregnancies in conjunction with other variable, then we may have to be a little bit more careful. Then we talk about the data exploration and visualization because both of them are the same. So the data set is not balanced with about twice as many data samples assigned to a value of 0, not by diabetes, but also assigned with a value of 1 with diabetes. But because in real life situations, sometimes it's hard to control. But in this case, we have this ratio almost 2 to 1. And then there is no linear correlation between the feature variable because, of course, you cannot compare yourself. But then in this case, the darker the color means that there is no correlation. We should look for the lighter the color. So maybe some, yes, they do age and pregnancies because usually the higher the age, the more difficulty you might experience in pregnancy. And then like this, like glucose and cholesterol, because like if you have too much glucose in your body, then they will then convert into cholesterol. Of course, they kind of correlation. But then again, you can notice that there are a lot of dark regions, which means that they don't have correlation or have very little likelihood for correlation. But also age and pregnancy and so on, and then okay, then the outcomes with the glucose and so on. So I want to spend a little bit of time on this slide because as you can see the BMI, you have a normal distribution, of course, but then you notice that when you have increased your weight, then you have the one that you might be very unique case. So as you can see, there are some outliers because you notice there's a correlation between diabetes patient and the weight. Usually they are overweight. When you're overweight, you tend to attract a lot of different problems. One of them can be diabetes, also might be high blood pressure, and also there can be certain unstable conditions in your health. So glucose level in theory, which is supposed to be low, and every day at different period of time, our glucose level varies between the time of the day. Usually when we are in hunger, then our glucose level tend to be low. And then you then stimulate another mechanism in your body. But then after having a meal, especially heavy meal, then our glucose level becomes very high. And then it's a time that the insulin will try to suppress it. But then for some people, they may not be able to suppress it to keep it to certain function. But then in this case, if most of the patient or most of the normal healthy people, if they don't overeat, and also they have exercises, most of them are still able to keep them in the normal range. They don't go too much on one end or the other. However, you may notice that when you begin to have problems in diabetes or you are overweight, you tend to rely more on glucose. So then you notice there's one observation: pregnancy, it has effects a lot. Not even at the middle, it's more inclined to the left. So you can see in this case, if you have pregnancy, it then can add further complication to your diabetes. But of course, I am not a medical doctor. I cannot give the kind of medical advice. But then, as a scientist, it's very important that we have to analyze those things that may affect the accuracy, of course. But then, of course, we need to know what may be the issues. So then, the classification report of random forest, we then perform various results. Then we then gets to the point that there are some other algorithm that seem to give a better performance. So in this case, the summary is that there are 135 represent cases with both actual and predicted diabetes negative. 27 represent cases with the actual diabetes negative and predicted positive. Yeah, so there were 34 represent cases with actual diabetes positive and predicted negative, and 58 with both actual and predicted diabetes positivity. So it means that we have a good accuracy in terms of 135. We got them, they don't. Yeah, and the actual result means that they don't. And we predicted 58 of them, yes, they do. They do have diabetes, but then again, yes, they are. But then there are some discrepancy because it's very complicated when you have pregnancies and maybe you. There are also people who are overweight, but they manage things well. They don't get diabetes. They may have a different type of disease. But then there are also people who do not appear to be overweight or anything. It may be because of genetic disorder, or maybe because the way that their body overreacts to insulin, and that is the reason that they then have diabetes. And then normally it comes to type 2 diabetes. So that is why sometimes we may have discrepancies in this. So based on the results, we have the precision of 68%, recall of 63%, and accuracy 76% in general. Then we then have the prediction probability output by random forest. The left side is the array, represent the probability of not having diabetes. And the right side of the array represent the probabilities of having diabetes. As you can see, they will make a comparison for this, and it will allows us to see any differences. Then we can see that the patient at index 0 has 99.7% chance of absence of diabetes. So the one with 0 means that they are very unlikely to have diabetes. But then the patient of index 1 has a 99.6% of predicted chance of having diabetes. It's almost like 0 means you don't have, then 1 means that you are highly likely to have diabetes. So this will be the result in other algorithms. So we have the decision trees in 90.54%, and the accuracy of SVM is 88.44%. So then we predict them, and then of course they have results that looks better that way. So we then focus on these two, and then it will give us a good result. So because we have done analysis of other types, so the emphasis of this talk is not about what method, but then about the meaningfulness of the result. But you see that diabetes influences the physical, psychological, social, and financial aspect of the individual. Therefore, there's a need to research further. Then glucose and BMI are both the primary factors of the medical indicator features for predicting diabetes. It is the ability of our algorithms that predict patients with diabetes. It adds complication if counting pregnancies. It is used to find some commonly used lab outcomes that are high with satisfactory sensitivity. We are not just like, getting the good result and then try to avoid the difficulty, but then we try our best to understand. If let's say we need to analyze something like complication with diabetes or other factors with glucose and BMI, or what caused them to rise in terms of glucose or BMI, like people all of a sudden gain weight in a short period of time or lose weight in a short period of time, that we also need to know, do they have any consequences to diabetes too? So a decision support system has been proposed that uses the random forest algorithm with decision and stumped as a base classifier for classification. However, support vector machine naive Bayes decision trees have additionally be executed as a base classifier for random forest calculation for exactness, if confirmation. As what we have observed is that although while dealing with some complications, involved with a sudden change in glucose and BMI, or maybe pregnancies, maybe random forest will be more consistent. However, if the patient under normal circumstances, if you never have diabetes, then of course other models will maybe more suitable, such as support vector machines and decision trees that we have shown and demonstrated in the slide. We have to really depend on case to case. If let's say you have some complication, then maybe we should use random forest. And if you are ordinary people, you show consistency in your health status, then of course you may use other machine learning algorithms. And despite of having 76% accuracy of random forest, is this considered good enough for the time being, considering analysis of BMI, glucose level, and pregnancy? Of course, we need to improve further and need to understand any dependencies in those variables. So why should you cite our paper? First of all, for this research project, we developed an application based on Python language for measuring the accuracy of a machine learning-based algorithm project. Then we use several AI-based algorithms to analyze and predict diabetes. As you can see, we already have 3 papers with different emphasis and a different research challenge, and we discuss our findings in a great depth, particularly focusing on BMI, glucose level, and pregnancies, which may add some complication. We could demonstrate our work and could replicate our work for similar analysis. Our future work will include analysis of the diabetes and other biomedical applications such as COVID-19. And of course, we will always try our best to analyze anything meaningful and try not to avoid any complication like a true scientist do. Therefore, you should cite our paper. And if you can, please visit our website. And we have 2 places. One is on IGI Global website. One is on ResearchGate. We make it free just for you. Yes. And we try our best to share our outcomes and disseminate in the community. And please cite or consider citing our paper if you find it relevant, helpful, or inspiring. Thank you so much for your time. We really appreciate it. We will meet again online very soon. Thank you so much. Have a good time.